Imagine a world where your thoughts alone could move a cursor on a screen, type a message to a loved one, or even play your favorite video game. For many, this has long been the stuff of science fiction, a distant dream confined to the pages of books and the silver screen. Yet here we are on June 29th, 2025, and this once fantastical notion is rapidly becoming a tangible reality. We are witnessing a profound shift in how we interact with technology, and more importantly, how we can overcome the physical limitations imposed by injury or disease. This is not just about convenience, it is about restoration, about giving back what was lost and unlocking human potential in ways we are only beginning to comprehend. This incredible leap forward is being pioneered by companies like Neuralink, whose work is pushing the boundaries of neuroscience and engineering. Their vision is clear: to create a direct communication pathway between the human brain and a computer. This brain-computer interface, or BCI, holds the promise of restoring abilities for people with severe paralysis, allowing them to reconnect with the world around them in a deeply personal and powerful way. The progress we are seeing today is the culmination of years of dedicated research, intricate design, and a relentless pursuit of what many thought was impossible. It is a story of science, hope, and the remarkable resilience of the human spirit. The journey to this point has been methodical and cautious, prioritizing safety above all else. Every step, from the initial device conception to the first human trials, has been guided by a commitment to ethical standards and rigorous scientific validation. The goal is not just to innovate, but to do so responsibly, ensuring that these powerful new technologies serve humanity in the best possible way. As we explore the breakthroughs of 2025, we are not just looking at gadgets, we are looking at a new chapter in medicine, one where the brain itself becomes the key to unlocking a healthier, more connected future for individuals facing some of life's greatest challenges. The implications of this technology extend far beyond a single device or application. We are on the cusp of a revolution that could redefine what it means to be human. By learning to speak the language of the brain, the intricate electrical signals that govern our thoughts, movements, and senses, we open up a world of possibilities. It is about restoring independence to those who have lost it and providing new avenues for communication and creativity. This is a moment of great hope, a time when the line between science fiction and scientific fact is becoming wonderfully, inspiringly blurred for the betterment of people everywhere. Neuralink's first major step into this new frontier is a device aptly named Telepathy. This brain implant is now being used by pioneers in human trials across the United States, the United Kingdom, Canada, and the United Arab Emirates. For these individuals, many of whom live with quadriplegia, the telepathy implant has become an essential part of their daily lives. It allows them to control a computer or a smartphone using only their intention to move. Imagine thinking about moving a mouse and watching the cursor glide across the screen in perfect synchrony with your thoughts. This is the reality for these early users, who are logging over 50 hours a week with the device. The impact on their lives has been nothing short of transformative. Participants are now able to perform tasks that were previously impossible without assistance. They can browse the internet, send emails, connect with friends and family on social media, and even engage in competitive online gaming. One user described the experience as regaining a part of themselves they thought was lost forever. The ability to independently control a digital device provides a renewed sense of autonomy and connection to the world. It is a powerful reminder that the human will can find new ways to express itself, even when the body cannot. This is technology that empowers and liberates. Consider the story of a participant who, for the first time in years, was able to play a video game alongside their friends. The joy and camaraderie they experienced were palpable. Before the implant, they could only watch. Now they are an active player, strategizing and competing using only their mind. This is not just about entertainment, it is about social inclusion and shared experiences. Another user has been able to manage their personal finances and communications, taking back control of important aspects of their life. These are not small victories. They are monumental steps toward a more independent and fulfilling existence, demonstrating the practical, everyday power of this breakthrough. The telepathy system works by interpreting neural signals associated with the intention to move. Tiny, flexible threads, implanted into the motor cortex of the brain, detect these signals. The implant then wirelessly transmits this data to a nearby device, like a laptop or tablet, where it is decoded into commands. The user simply thinks about where they want to move the cursor, and the system translates that intention into action on the screen. The process is intuitive and becomes more seamless with practice, as the user and the system learn from each other. This symbiotic relationship between mind and machine is what makes the telepathy implant so revolutionary. Building on the success of telepathy, Neuralink is now turning its attention to another one of the human body's most complex systems, vision. The company has announced its next groundbreaking project, a device called Blindsight. This ambitious initiative aims to restore a form of vision to individuals who are blind. Unlike treatments that target the eyes, Blindsight is designed to bypass the optical system entirely. It works by directly stimulating the visual cortex of the brain, the region responsible for processing sight. The goal is to create a direct perception of light and shapes, effectively allowing the brain to see without information from the eyes. The concept behind Blindsight is both elegant and incredibly complex. The device would receive visual information from an external camera, perhaps mounted on a pair of glasses. This information would then be processed and translated into patterns of electrical stimulation. These patterns, when delivered to the visual cortex via the Blindsight implant, would ideally be interpreted by the brain as a rudimentary form of vision. The initial goal is not to replicate natural sight in all its richness and detail, but to provide a functional visual sense that could help individuals. Media group, animation or diagram of brain implant stimulating visual cortex, medical device sending signals to brain, neural implant in use at stock, distribute equally, navigate their environment, recognize objects, and regain a significant degree of independence. The potential impact of Blindsight is immense. For millions of people around the world living with blindness, the prospect of regaining any level of vision is a source of profound hope. Imagine being able to perceive the outline of a doorway, the shape of a loved one's face, or the simple presence of light in a room. These fundamental experiences, which many of us take for granted, could be restored. The journey for Blindsight is just beginning, with early research and development paving the way for future human trials. The lessons learned from the telepathy program will be invaluable in guiding this next chapter safely and effectively. The technology that underpins both telepathy and Blindsight is at the cutting edge of modern science. Neuralink has developed its own custom application-specific integrated circuits, or ASICs, which are powerful miniature computers designed to process vast amounts of neural data in real time. The implantation of these devices is performed by a sophisticated surgical robot, engineered to place the delicate electrode threads with a precision far beyond that of the human hand. This combination of bespoke hardware and robotic surgery not only enhances the safety and accuracy of the procedure, but also streamlines the workflow, making the entire process faster and more efficient. Looking ahead, Neuralink has laid out an ambitious roadmap that extends well beyond cursor control and basic vision. By 2028, the company aims to tackle even more complex neurological functions. One of the primary goals is speech decoding. This would involve developing the technology to translate the neural signals associated with intended speech directly into audible words or text. For individuals who have lost the ability to speak due to conditions like ALS or a stroke, this could be a life-changing breakthrough, allowing them to communicate their thoughts and feelings fluently and naturally once again. The roadmap also includes support for multiple brain implants working in concert. This could open the door to more comprehensive therapies. For example, a person might have one implant to help control movement and another to assist with speech or sensory perception. The ability to create a network of devices within the brain could lead to more holistic solutions for a wide range of neurological disorders, from restoring motor function after a spinal cord injury to potentially treating conditions like severe depression or epilepsy. This multi-implant strategy represents a significant step toward creating a more versatile and powerful therapeutic platform. Throughout this entire journey of innovation, a steadfast commitment to safety and ethics remains paramount. Every human trial is conducted under the strictest regulatory standards and with rigorous oversight from independent review boards. The well-being of the participants is the absolute top priority. As Neuralink moves forward, maintaining this culture of ethical responsibility will be crucial for building public trust and ensuring that these technologies are developed and deployed in a way that truly benefits humanity. The path forward must be paved with both bold ambition and profound caution, balancing progress with principle. We are standing at the dawn of a new era in human health and capability. The work being done today is transforming concepts once relegated to science fiction into real-world solutions for real people. The development of brain-computer interfaces like telepathy and Blindsight is not just a technological achievement, it is a beacon of hope. It signals a future where paralysis may no longer mean isolation, and blindness may no longer mean darkness. As this technology continues to evolve, it holds the potential to help countless individuals around the globe, proving that with ingenuity, dedication, and a focus on our shared humanity, we can overcome even the most daunting challenges.